If you picture the dark web based on Hollywood movies, you probably imagine a mystical digital underworld filled with hackers typing glowing green text in real time. That image is a complete fiction. In reality, the dark web is simply a specific network architecture. It is built on a strict set of cryptographic protocols designed to guarantee total mutual anonymity between the person browsing and the server hosting the content. Many enterprise cybersecurity teams struggle in this environment because they apply standard search-based logic to a space that requires high-volume data engineering. To understand how threat intelligence is gathered, we are going to deconstruct the mechanics of onion routing, explain why 56-character version 3 addresses cannot be tracked, and reveal how offline vault monitoring operates. We will also look at the massive technical and operational security, or OPSEC, roadblocks that prevent companies from simply building their own proprietary dark web crawlers. OPSEC refers to the process of identifying and protecting sensitive information that could be exploited by an adversary. Mastering dark web threat intelligence requires abandoning Hollywood hacker fantasies and understanding the underlying cryptographic engineering that makes this network function. Let's start with the baseline. On the standard surface web, your browser connects directly to a host server. Your computer knows where the server is, and the server knows your IP address. Dark web traffic operates differently. To access it, your data must be routed exclusively through the Tor network. Tor is an acronym for the Onion Router. Tor wraps your data packet in 3 encryption layers. The entry node strips the first layer. The relay node strips the second, obscuring your origin. Finally, the exit node strips the last layer and delivers the raw data to its destination. The security design relies on isolation. No single node in this chain ever knows both the origin of the data and its final destination simultaneously. This layered physical infrastructure, powered by dense racks of decentralized hardware managed by volunteers globally, makes network surveillance and traffic analysis incredibly difficult for law enforcement. Onion routing is a math-based distribution of trust. It prevents direct network tracking by structurally compartmentalizing routing information. Because of this routing structure, there is no equivalent to Google for the dark web. It completely bypasses the Standard Domain Name System, or DNS. DNS is the system that translates human-readable domain names into numerical IP addresses. Instead, the Tor version 3 format uses a 56-character alphanumeric string ending in .onion. This string functions as a cryptographic public key. This public key ensures a user is connecting to the exact hidden service they intend to reach, authenticating the connection without ever revealing the server's physical IP address or geographic location. Operators of illicit marketplaces frequently change these cryptographic addresses to evade detection. This creates extreme volatility. A forum that is active today might completely vanish tomorrow. Because these URLs act as cryptographic keys rather than static locations, the dark web successfully resists being mapped by automated search engines. Commercial dark web monitoring tools do not execute live, real-time queries on the Tor network when they alert you that an employee credential has been compromised. The data originates from external breaches. Cybercriminals hack into organizations, steal massive databases containing millions of usernames and passwords, and then dump those databases onto illicit dark web forums. Security companies act as middlemen. They employ automated bots and human threat researchers to infiltrate these forums, navigate the sophisticated supply chains of these hidden marketplaces, and secure the data dumps. These researchers pull this chaotic, unstructured text data completely off the Tor network and transfer it to the clear web. The data is standardized into an offline vault, a secure SQL database hosted on the standard internet. When an enterprise user queries a credential through their dashboard, the system cross-references this offline vault, never pinging the dark web directly. This asynchronous methodology is required to protect the end user's identity and corporate network from severe exposure. The user's instant search results represent the final stage of a long pipeline involving massive, asynchronous data engineering and offline storage. Given that data harvesting drives this entire pipeline, a well-funded corporate security team might consider building their own Tor crawler to find leaked data. The first roadblock is extreme instability. Dark websites are often hosted on low-quality private servers that constantly throw 404 connection errors. A custom crawler must be continuously maintained just to discover new active URLs. The second roadblock is anti-bot defenses. Paranoid illicit marketplaces deploy complex CAPTCHAs, along with rate limiting and honeypot links to actively trap automated scrapers. A CAPTCHA is an automated test designed to distinguish human operators from software. Even if you bypass defenses, you hit the next roadblock: unstructured data. The scraped files exist as chaotic, fragmented text, requiring intense engineering to parse. Beyond the technical hurdles, there is a massive operational security risk. Running a crawler without highly secure, non-attributable infrastructure risks exposing the entire enterprise network directly to threat actors. This is why mature organizations rely on pre-parsed commercial threat intelligence APIs, like SpyCloud or Flare.io. These services pipe clean data directly into an enterprise's SIM. SIM is an acronym for Security Information and Event Management, which is a system used to monitor and manage network threats. For an enterprise, the dark web is an unstructured data parsing problem, not a live infiltration mission. Buying intelligence is more effective than building a scraper. The architecture of the dark web is built to frustrate direct observation. Onion routing structurally obfuscates the source of the traffic through layered encryption. At the same time, those 56-character cryptographic .onion URLs hide the destination server. Security companies bridge this gap by asynchronously extracting unstructured data dumps into safe offline vaults. Extracting actionable intelligence from this environment is the result of continuous data collection and strict operational security. It is not accomplished by simply typing a query into a search bar. Enterprise teams should leverage commercial intelligence feeds over direct Tor crawling, unless operating with a cleared legal mandate and a team of dedicated threat hunters. True enterprise security comes from safely engineering the data the dark web leaves behind.